Hello everyone, welcome to the Fluid Mechanics Lab. Here we're demonstrating the hydrostatic pressure experiment. It's a very simple experiment, and as the name suggests, hydrostatic pressure is simply the pressure that is exerted by a fluid at equilibrium in a given point within the fluid. There are two main objectives for this experiment. The first of which is to determine the hydrostatic thrust force acting upon a plane surface that is submerged partially or fully into the fluid. And the second objective is to measure the line of action of the hydrostatic thrust force that is determined prior, and to compare these values with the theoretical values that can be calculated using the given equations. I will initiate the demonstration by taking you through the apparatus of the experiment. Here we have a water-sealed flotation tank, which is placed upon a base that comes with 3 adjustable legs, a spirit level, and a drainage valve. And at the top of the tank, we have the knife edge pivot and the level indicator. Over here we have weights and the weight hanger, and of course the protagonist of the experiment, the quadrant. The quadrant comes with a pre-installed scale, and it is attached to a arm balance, a counterbalance at the arm balance, a knife edge pivot, of course a clamping point, and at the edge of it we have a groove to attach the weight hanger. Of course, last but not least, we have a bucket of water to fill the tank later on when we demonstrate the experiment, and we have a drainage tank. So the initial step for the experiment is to ensure that the surfaces of the quadrants are dust-free, and we can do this by using ideally a damp rag. Here I have prepared a damp rag that we can simply wipe the surfaces of the quadrant carefully to ensure they are dust-free. And with this, we can move on to the further steps. So to start the experiment, we need to ensure that the apparatus here, the tank, is at a level surface. And we can do this by adjusting the adjustable legs and using the spirit indicator to ensure that the surface is level and flat. We would then take measurements, 4 measurements to be exact, for future reference for calculation purposes. The first measurement is the height of the quadrant end surface and the width of the quadrant's end surface. We would take the measurements as such and note them down. And the other 2 measurements we'll be taking are the length of the balance arm and the height from the pivot point to the bottom of the quadrant's end surface. And we will take the measurements as such. So the measurement of the length is going to be from the pivot point until the grooved surface here. And the height is going to be from the bottom of the pivot point until the bottom of the quadrant's end surface. We would then proceed by placing the quadrant into the flotation tank and hanging the weight hanger at the groove point here, and adjusting the counterbalance to ensure that the balance arm is at the central point of the level indicator. You need to wait for it to balance and stop. Once this procedure is completed, we will add the weight of 50 grams into the weight hanger and input water into the flotation tank until the balance arm is back at the central point of the level indicator. An important thing that we need to take into consideration is that when we're inserting the water into the tank, we need to make sure that the arm is not wet. We should not have water on the arm or the quadrant's surfaces. We should directly pour the water into the bottom of the tank. As you can see here, the acting hydrostatic forces, or thrust force, is bringing the quadrant back up into the central point, as you can observe. So we need a little bit more water. So now that we filled the tank to a point where the quadrant is back at the central point in the level indicator, we need to measure the level of the water using the scale that is pre-installed on the quadrant. As you can see here, it is at 40 centimeters away from the surface, meaning the water depth is at 40. So after doing so, we place another weight of 50 grams onto the weight hanger, and repeat the process of adding water into the tank. And of course, to bring it to the center, we can take advantage of the drainage valve we have. And repeat the process until we use all 500 grams of weight we have here. So now that we have filled the tank up to the end and used up all 500 grams of the weights, and of course taken all the measurements down for future calculation, the next step would be to remove the weights and reverse the process. We would empty the tank using the drainage valve and continue and repeat the process continually until we no longer have weights on the weight hanger. As you can see here, the balance arm is at the central point of the level indicator. We would proceed on to take the measurement that is indicated at the scale that is attached to the quadrant. And we repeat the process until the tank is empty and the weights are no longer attached to the weight hanger. Alright, with that, we have completed the experiment. We reversed the process until we used up all of the weights, and we ensured that the balance arm is at the central point of the level indicator. With that, you have completed the experiment, and hopefully you can discuss the possible errors, experimental errors that could occur when performing this experiment, and discuss it with your group mates in your reports. Thank you.